Hi everyone, welcome to the lab. Look what I've got on my bench. This is a Pioneer Elite receiver, model SC09TX. This is a high-end receiver, super expensive, super heavy, and it stopped powering up. Perhaps you can see this LED is flashing, and when I try powering this thing up, nothing happens. Let's take a look. Here is the back of the unit. Made in Malaysia, August 2008. Apparently this bottom part is a 10-channel amplifier, and here we have so many connectors, all sorts of digital and analog inputs and outputs, even a network port and the RS-232 serial interface. So let's open it up and have a look inside. I unscrewed this top cover and look at this. Here we have these vent holes, and there is a bug, and I don't see any protective coating on this board. I wonder if something like this might be a problem. Here we can see a couple of massive transformers and some power supply stuff with some fuses and such. So I think this should be checked first. I managed to remove a side panel, trying to understand how do I even begin to reach some stuff in here. And I keep seeing power supply looking modules like this one here. There are some fuses and capacitors and such. And there is one more. Let's see. A power supply looking board on the other side. I see some high voltage connectors and filtering and so on. Alright, I managed to remove this HDMI board which was sitting here, and also this piece of metal which was right under it, and I'm still struggling to understand how to dig any deeper into this thing. It is quite complex and is packed with all sorts of boards, and I have to organize the screws so I have some chance of putting this thing back together. I removed the other side panel and this power board I showed before with high voltage connectors. I started checking capacitors, and in particular I don't quite like this capacitor, 220 microfarads, 25 volts. There is another 220 microfarad capacitor here, slightly smaller one, 16 volts rated, and usually larger capacitors have lower ESR. So let me show you. This larger one has about 0.7 ohms ESR and about 112 microfarads capacitance at 1 kilohertz. And this smaller one is here, and it has about 0.5 ohms ESR and about 134 microfarads capacitance. So there is a chance that it is going to look better out of circuit, but so far it seems like it is a bit degraded. Not too bad. I doubt it's the reason the unit does not power up. But still, I would probably replace it just in case and keep looking. Here it is desoldered, and it looks a tiny bit better out of circuit, and that is probably because it was heated up during desoldering. And just for comparison, I found a similar size Rubicon 220 microfarads 35 volts capacitor, and this one looks much better, much higher capacitance and much lower ESR, but I am not entirely sure that this was a problem. Maybe this one is in spec if we manage to find a datasheet for that exact model, and this is just a better model with lower ESR or something like that. So I'm tempted to put a better one in, but I don't think this was a problem. I managed to detach the bottom part, which is the power amplifier. I'm not sure it was necessary, but I want to have a look anyway. We can see these 10 shielded cables, must be inputs to all the channels. We can see this ribbon cable and some other connector. Could be some sense and control, and might be something wrong with that, and it can be the reason the unit doesn't want to turn on. These are some power rails, I believe. There is some other power connector here, and this looks like a fairly standard mains connector. So I wonder if that top part can be powered up without this bottom part. I'm not sure it's gonna work with all this stuff disconnected. Here is the power amplifier. We can see 10 pairs of MOSFETs in the output stages. And this is a switch mode power supply. And it seems to me that all big caps are bulging. I'm not entirely sure because they all look the same. Is it possible that all of them are bulging exactly the same way? These smaller ones are flat, but these are definitely bulging a bit. So I'm almost sure this is not right. So I removed the power supply to take a closer look, and also I found a service manual for this thing with all schematics except these two boards, power supply and the power amplifier board. And I think I see why. It seems like these two boards were produced for Pioneer by another company. Look at this. Bang & Olufsen on this board, and here on the power amplifier board, Bang & Olufsen. Let's take a closer look at this power supply. This is the primary side up to this isolation gap, and there are several optocouplers across it. This is the secondary side, and the big caps do feel a bit bulged, but when I measure them, they don't look too bad. Let's see, these are 6800 microfarads, 80 volts on the secondary side. So let's grab my LCR meter, switch it to 100 Hertz and ESR, and let's have a look at this cap. About 5300 microfarads and about 30 milliohms ESR, and this one about the same. And these are 1800 microfarads 200 volt capacitors, and I believe these are arranged as two parallel, two series configuration. So we should see about 3600 microfarads, and we see about 2900, and also about 30 milliohms ESR, and I'm not sure which are paired with which, but all of them look about the same. So maybe they are a bit low in capacitance. ESR looks fine, so perhaps they are degraded a bit, but I don't think this is our problem at the moment. So let's worry about them later. So I'm looking at this power board and the schematic, and I see that the top part receives mains power from this point without any switches through this cable, and this connector is to control these three relays and these two fans. These two relays are to switch on and off both sides of the mains input to this switch mode power supply for the power amp. And the third relay is to bypass the inrush current limiting resistor after a while. So nothing here is turned on until the top part decides to turn it on, and it does not even try. So I might be wrong, but it seems to me that this power amplifier has nothing to do with the problem. Maybe these capacitors need to be replaced, I'm not sure about that, but at least it's not the primary problem. Here is the top part separately, and I have this mains power cord with a connector which fits this, and I tried powering it up, connecting the front panel back, and I see exactly the same behavior, just a flashing LED and no reaction to the power button. This is the schematic for the primary board. We looked at this board before. In particular, we checked this electrolytic capacitor. This is the one I desoldered. It looked a bit degraded, so I replaced it. And this voltage regulator is supposed to produce 5.6 volt standby rail, which is always on if the unit is plugged in. And the rest of the unit, except the power amplifier, is on if this relay is on. And it's not clicking for some reason. Here is the mains input from the bottom part, going through some filtering, then through this relay and to a couple of transformers, powering analog and digital parts separately. So we need to start checking things here. We need to find out why this relay is not clicking, and perhaps we should start by checking this standby power rail. Let's check the standby rail. Here it is, 5.65 volts, no significant ripple, looks fine. This is the Mother 1 assembly schematic, and this is the main system microcontroller. This pin controls the AC relay in the power supply, and these two pins control the relays in the power amplifier. And also, among other things, this microcontroller talks to another chip in the infrared and RS-232 assembly. Here it is. This chip is called Event, and there are several pins there dedicated to talking to that chip. Event data in, data out, clock, request, ready, and reset. Back to the event chip, we can see that it is also involved in powering things up. This pin is called power key, and it is connected to the power button on the front panel. This is power LED pin, which controls the LED in the power button. And this is combined with another signal. I believe this is AC relay for some reason. There are several LEDs connected to this chip. These are on the front panel, and this one is flashing. And here we have these pins to talk to the main microcontroller. Event clock, data in, data out, ready, request, and reset. This chip receives power from the 5.6 volt standby rail through these diodes to combine with some other rail, and after a typical diode voltage drop it becomes V50U, and here it is. And after a filter, which consists of this inductor and capacitor, it becomes V50E, and this rail powers up this chip. So here is this event chip on the RS-232 interface and infrared control board, and I found that its reset is always high. So I think it is held in the reset state by the main microcontroller, which is buried somewhere over there on the main board. And the reset is coming from that microcontroller to this chip, but not directly, because this chip is running at 5 volts and that one at 3.3. So there is a level shifter somewhere on the main board. So I will need to remove some boards to start checking there, and I wish I knew which boards are optional, so that the unit should at least power up without them. Alright, I managed to remove the back panel and a few boards, and I am already afraid that putting this thing back together is going to be quite a task. Fortunately, the service manual describes which connector goes where and even which screw goes into which hole, but still, there are so many screws and connectors that it's gonna be difficult. Anyway, let's worry about finding the problem first, and then worry about putting this thing back together. So, I started checking around this main microcontroller. The 3.3 volt rail is fine. So, I checked this reset chip. I found a datasheet for it. And from the datasheet I found that the output reset pin is inverse, meaning active low, and it is high during normal operation. But the reset pin on the micro is not marked as inverse. So I'm thinking maybe it's the same thing with this event chip. The reset pin is not marked as inverse, but perhaps the high level here is fine, and the problem must be with something else. There is a ceramic oscillator here next to the chip, 15.7 MHz to generate clock, and I don't think it is running. Look at this. We have high level on one side and low level on the other side, and there is no oscillation. I don't like this at all. Either this resonator is faulty or the chip is dead, and in that case I don't like my chances at all, because it's a microcontroller with firmware in it, and if it's dead this thing is hopeless unless these motherboards are available. So I temporarily hooked up a 16 MHz quartz crystal instead of the resonator, and now the clock is running. So I hooked up this logic analyzer to monitor a few things here, in particular data communication with that event chip, and I do see communication both ways, so both chips must be alive, but still there is no reaction to the power button. And now I wonder, is it possible that 16 MHz clock does not match some other clock? Let's say that event chip also has 15.7 resonator. Or maybe something else is wrong, or perhaps the unit would not power up without some boards installed. So many unknowns. Here I captured the first 10 seconds after plugging this thing in. The trigger was set here on the rising edge of the 3.3 volt rail. This line is the reset of the main chip, and these are lines to communicate to the event chip. Event reset, event ready, request, clock, data out and data in. So let's take a closer look. Here the 3.3 volt rail came up, which happened at about 16 millisecond offset. And after about 10 milliseconds the reset of the chip was deactivated, which works perfectly fine as expected. And after a while this exchange happened. In particular, if we zoom in here, we can see a few data packets going both ways. And all that was happening up to this point, let's say 3.3 seconds, and everything was quiet after that. And now I moved the trigger here to the event request, which comes from the event chip to the main microcontroller, and when I press start it is waiting for the trigger, and when I push power button this exchange happens. For about 2.6 seconds there is some data communication, quite a few packets here and some more here and so on. So this activity happens after push of the power button, but still the receiver remains in standby. And here I added a AC relay line from the microcontroller, and this is the same activity after a push of the power button. And as we can see, there is nothing here, so the microcontroller does not command the power supply to turn on. After some searching online, I found that this thing can get stuck in some error state and it needs to be reset using some magic combination of these buttons on the front panel. And people mentioned some combinations and I tried some of them and I got it out of that state. I think it was multi-zone control and tune up or tune down or something like that. 2 buttons for a few seconds, and now the behavior has changed. Now it responds to power button. Relay clicks, this stops flashing for a few seconds, then relay clicks again, and this starts flashing again. Let's try. There was a click. No flashing for a while, another click and flashing again. So I guess something else is wrong, or maybe this is happening because something is not connected. Power amplifier, for example, or maybe even a fan or something like that. But I guess something else is wrong. I would imagine it should turn on the display and say something if it could. So perhaps some power rail does not come up or something like that. I am using a 15.9 MHz quartz crystal there. This is the closest to 15.7 I could find, and I hope it's good enough. I connected the bottom part and now there is no flashing here and this thing turns on and stays on. But there is no display and no light in the power button. I still did not install the HDMI board. Can that be the reason that display is not working? I doubt that. Here is the front panel, and here is the power button with LED, and also a transistor to turn the LED off and on, and a current limiting resistor, 150 ohms. And I measured across the LED when the unit is on, and I measured 5 volts, as if the LED is open circuit. Here is this little board, and it seems like the LED is dead. I desoldered the LED and it seems to be working. Look at this. 2.6 volts, and do you see the blue light? What's going on here? I soldered the LED back and it's working. Go figure. Look at this, I was wrong. I installed the HDMI board and now we have the display. How cool is that? So I hooked up this pair of good old Sony speakers for testing, just front, left and right channels, and I hooked up this Korg machine. Let's give this a go. So I will put this thing back together later. That's quite a bit of work. And I still have to decide what to do about those big electrolytic capacitors in the power amplifier. Please let me know what you think about that in the comments below. Thanks for watching. Bye.